Now we're going to take the next step with linear equations. We talked about equations, we talked about graphs, the slopes, the distances between 2 points, and how to find equations of lines. Now we're going to take that one further. We discussed functions before. What's a function? Or I thought we did.
Function is, well, if I were to put in my homework, the function is a linear equation that's wrapped out on.
No, it's a function can be any equation. It's just any equation. We've just been limited to linear equations. You're going to see in the next few chapters, we're going to cover an infinite number of types. Well, there are 14 types, 12 or 14 types, but there are infinite ways you can put them. You can combine them. So you have infinite number of functions. So basically a function is an equation. Function is represented like that. And the equation is y equals some equation. So what this is saying is f of x is the same thing as the y. They both equal 3x plus 2. So now, what we have to do, we have to take that concept, because we've learned how to graph those. Remember how to graph linear equations? How do you graph them? What are the procedures?
Well, it's taking the form of y equals mx plus b. So
Yes.
you establish what m is and what x is on maybe or b.
Yes.
So give you your slope and your y-intercept.
Yes.
And then you can plug in different coordinates.
No, that's the hard way. Yeah, you're right up until that last statement. So to graph linear equations, put into y equals mx plus b. What's the name of that form? Slope-intercept form, because we have a slope and we have the y-intercept. Identify your slope and your y-intercept. First thing you do is plot your y-intercept on the y-axis. Whatever b is, you put a dot on that value. From that point, from that b, follow the slope to the next point. That's all there is to it. And you can do that infinitely.
Mine's a lot easier.
But you were right up until this very last step. Because I don't know if you said plot some points. Yeah, you do, but the only point you have to plot is the y-intercept.
Yeah, you don't have to actually solve.
And zero calculations, exactly, yeah. The problem with this is if b is a fraction. If b is a fraction, then find an intercept. It doesn't matter which one. If it's the x-intercept or the y-intercept, if one exists, that's even better. If two of them, that's great. You just connect the dots. But if all you need is one of them, because once you find that point, you follow the slope from there. You don't need your computer open in this class, not until yet. So go ahead, close your computer, because we wouldn't need computers in here. Because everything I'll be giving you. So that's if you have a fraction. Try that. If that doesn't work, if that doesn't work, find a point, any point on the graph. How do you do that? Plug in an X or Y and solve for the other. Because you need to have something solid, two integers that intersect somewhere in this two-dimensional space. Once you find a point, then you can follow the slope from that point. So far, so good. Now, we're going to go a little bit further because this next concept will take us through the rest of the course. You ever finished? The concept of zeros. We are asked to solve an equation. Why are we asked to solve an equation?
Is there unknown variables and has to figure out what.
Something else that tells us, yes, there has to be a variable in there. There could be one or more. But what tells us we have to solve for it is an equation has an equal sign. If it's got an equal sign in it, what first thing you got to do is move the numbers one side and the variable to the other side. If you have two variables, pick one of the variables, move it by itself, everything else on the other side. There is the problem. That's an equation. We isolated a variable. Nothing to do here. Because all we do now is just take some x's, plug them in there, and find some y's. What if your slope was a fraction? The choice of x is yours. Make it a logical choice. So what would be logical choices for x? Make it 0. Make it -5. Make it +5. -10, +10. Oops. +10. In other words, since this is the denominator of 5, we want to make x into a factor of 5 so they cancel. Because if you put 3 in there, then you have 12/5. Good luck. And then we have to go through a whole set of processes, which we're going to talk about in a second. So if you have an equation and it's a fraction, then be conscious about what value you pick to put in for x, because you want it to cancel out with the bottom number. Equation solving principles. Typically, in the beginning of the semester, I start off with all the properties and all the principles and the procedures of mathematics. But since it's incorporated in this section, we'll wait till here. The first one is the addition principle. What the addition principle says is this. If you have, let's say if A equals C, whatever you do to one side, you have to do the same thing to the other side because of the equality. It's like a seesaw. Well, most kids don't know what seesaws are. Think about it. This generation's never been on a seesaw. Yeah, you have to be older than 25, 30 years old to know what a seesaw is, or even one of those little, those little wheels of death, jungle gyms. But whatever you do to one side, you have to do the same thing to the other side. If I add to A, I have to add to C. If I subtract from A, I have to subtract from C. Now, what is that? Why is that important? Let's say we had 3x plus 2 equals 5y minus 7. Well, no, let's make it 5y. Let's make it y. We're solving for y. To get y by itself, what do we have to do? To get y by itself, what do we have to get rid of? The negative 7. How do we get rid of negative 7? Add 7. Whatever we do to one side, we got to do it to the other side. So we have 3x, since they're both positive, same sign, add the numbers, and these cancel. Bless you. That's called the inverse property. Is to get rid of something that's added and subtracted, just do the opposite to it. All right, that's the first property or principle. The second is the multiplication principle. Same thing. If we have a statement that says A equals C, whatever we multiply to A, we have to do the same thing to the other side. So if we take A times B, then we have to multiply B to the other side. So does subtraction work the same way as addition? If you subtract something from one side, you have to subtract from the other? Yeah. So addition and subtraction are opposites of each other. So what's the opposite of multiplication? Division. So it also can be expanded to the division principle. If I have A and that equals C, and I divide A by B, then I have to divide C by B. Whatever you do to one side, you have to do the same thing to the other side. Example here. 3x equals 9y. Let's pretend we're solving for x this time. We want to get x by itself. We have to get rid of 3. How is 3 connected to x? Well, these are multiplied. How do we know it's multiplied?
This 3 can go into 9.
Nope, that's not. I'm just looking at this side. I'm just looking at this side. How do we know that 3 is multiplied to x? Sure.
That makes sense.
Well, no, it is true. Multiplication, you're absolutely correct there. Is there a plus sign between there? Is there a minus sign? Is there a division symbol? So multiplication, as what you said, is the only operation that doesn't have to be there to be there. In other words, for multiplication, we can have 3 times 5. We can have 3 times 5. We can have 3 times 5. So there's nothing between there. That means automatically multiplication. So you're absolutely right, because there is a multiplication between there. The way you read this is 3 times x. The most common mistake students make, I'm not saying you're going to do that, but if I gave you this and I said that x equals 2, what's wrong with that?
That's 32.
That's 32. No, but it's a logical idea, but it's not how it works, because this is 3 times x. So whenever you plug in numbers inside of variables, make sure you put them in parentheses. So since this is multiplied, what's the opposite of multiplied? So we divide both sides by 3, because we have to get rid of that one. And then 3 goes into 9 3 times. Those are what we're going to need to isolate our variables, because now we're solving for it. Let's look at this. Because now that we're solving, the word solution is synonymous with a couple of other words. First off, I have to ask you, what does solution mean in a math problem? What does it represent? Yes, but graphically, what does it do? Yeah, all those are correct. But what does it represent? So the word solution is the same as x-intercept, the root of the equation, which we're going to talk about later on, the 0, or the factor. All of those are synonymous. They're done the same way. So basically, if you're asked to solve it, you're finding the intercept. So get our brains working here. Solve for x. I don't even have to tell you what to do. It tells you what to do automatically, because there's an equal sign. There's one variable. Automatically, it tells you solve for that x. It's implied. How do we do that? Order of operations. The order of ops. Special operations first. Multiplication, division second. Addition, subtraction third. That's the order of operations, the way we simplify equations. When we solve, we do it that way. Except the special operations always has to go first anyway, because the reason that is because like a parenthesis separates an equation into multiple parts. So looking at this, are there any special operations? The parentheses. Here's one parenthesis, and here's another. They're opposite sides of the equal sign, so we could do them both at the same time. So we found a special operation. So we look inside it. Can we do anything inside there? Are there any special operations? No. We can't do multiplication, we can't do subtraction. So since we can't do anything there, we have to get rid of the parentheses. How? What's that called? Distributivity. Distributivity is a powerful concept. We'll go over that in a second. Basically, all it's saying is this. Whatever's in front, to get rid of the parentheses, whatever's in front multiplies to everything inside there. And after we finish this example, I'll show you why that's a powerful. We'll be using that equation more than anything. So this first one becomes 2 times 3 is 6x. Positive times negative is negative. 2 times 5 is 10. Positive times negative is negative. 4 times 5 is 20. Positive of, hold it, bad, reverse. We have a special operation here. Can we do anything inside there? We could do negative 5. So we could do inside there first. So what is negative 5 plus 2? Yeah, since we have different signs, since 5 is bigger than 2, the answer is going to be negative. Since we're different signs, we subtract. 5 minus 2 is 3. Parenthesis, we can't do anything inside there, so we have to get rid of it. Positive times negative is negative. 4 times 3 is 12. Would we have gotten a different answer if we didn't do inside the parenthesis first? Good answer. Yes, it has to be. Let's see. Let's see here. 4 times negative 5 plus 2. So positive times negative is negative. 4 times 5 is 20. Positive, positive, positive. 4 times 2 is 8. There's opposite signs. So I take the sign of the larger number. It's negative. So I subtract them. 20 minus 8 is negative 12, which is the same thing we have. So it doesn't matter which way, it gets the same answer. I will always try to, I'm going to ask you questions to make, see if you can doubt yourself. If you doubt yourself, you're not really sure about your answer. And that's why I want you to be confident of each step. And you can be very confident if you know the rules and you apply the rules. In other words, if you're driving a car and you have a green arrow that says you could turn left, and you turn left and somebody hits you, who's at fault? Yeah, because you had the rules. Okay, so now what do? We're solving for x. What do we have to get rid of? Look at this. Now that we have no more special operations, we start from the bottom. Get rid of anything that's plus or minus wherever you're solving. So I'm solving for x. Are there any pluses or minuses? Yes. So that's minus 10. How do I get rid of minus 10? Plus 10 to both sides. That gives us 6x. Okay, they both have different signs. So 12 is bigger, so it's negative. 12 minus 10 is 2. There are no more pluses and minuses. Is that a minus? No. There's a difference between that. That sign is a what? Minus. Because 5 minus 3 is 2. This is a negative 3. Theoretically, they're both the same thing, because what this means is 5 plus negative 3. But if there's numbers to both sides, it's a minus. If it's in front of a number by itself, nothing else, it's a negative. So my last step, are there any more plus minuses? No. So I have to do multiplication division. I have 6 times x. What's the opposite? Divide by 6, both sides. So there's negative, positive, so the answer is negative. 2 goes into 2 once. 2 goes into 6 3 times. And there's your answer. From this point on, besides these steps that we're showing you here, there's one extra step that you have to do at the end if you want to make hundreds. The last step should always be, what does CYA mean? No, it doesn't business. It means exactly, check your answer. That's exactly right. Because ideally, it's very true. That's very true. Ideally, you should know your grade before you ever press send. If you check the answer and it's wrong, then something went wrong. Either the procedure went wrong or the way you checked it was wrong. Something didn't work. So when you check your answer, if I put negative 1/3 inside here, let's go ahead and work that out. So let's check it. So I have the equation. This is my CYA. That is so true. It is covering your posterior. When x equals negative 1/3. Let's see how we would check that. Anywhere seeing x, plug a 1/3 or negative 1/3. So I'll just take that, plug it into the only x I see. Because they're on opposite sides of the equal sign, I could do them both at the same time. I have to do inside the parenthesis. Positive times negative is a negative. The 3's cancel, which just leaves me with 1. And then this minus 5. Inside the parentheses, they're both negative, so the answer is going to be negative. 5 plus 1 is 6. If the signs are the same, write the sign down and add the numbers. If the signs are different, take the sign of the larger and subtract the numbers. 5 minus 2 is 3. Positive times negative is negative. 2 times 6 is 12. Positive times negative is negative. 4 times 3 is 12. That means that's your answer. So should there ever be a point where you get anything less than 100? Theoretically, no. Because you know you can check your answers yourself. Are you going to do it? Same answer. Probably not. Which is why I have no sympathy. I don't really curve test grades. Because you have the chance to tell me if it's right or wrong before you ever send it to me. If you're too lazy to do it, I'm going to be too lazy to do any extra work. So let's look at this. So that's the procedural aspect of it. Let's look at our example sheet. Example 1. We have 3/4 x minus 1 equals 7/5. I really think the first two should have been switched, but I'm glad they put this one in there. Here's a general rule that's going to follow you the rest of this course and all math courses. If you have a fraction or fractions and an equal sign, then get rid of the fractions. Get rid of the fractions. Typically, 70–80% of the students, when they see a fraction problem, they get nervous. And this part's going to remove that. So this is what it looks like now. And these next 5 steps are always going to be used. Here are the steps. First step. Find the LCD. LCD stands for least common denominator. What's the smallest number that the bottom numbers both fit into? 20. The LCD cannot be smaller than either of these. In other words, if I had 2 and 8, the LCD is not 2 because 8 does not fit into 2. The LCD has to be as big or larger than the denominators. So in this case, it's 20. 4 times 5. If you don't see it automatically, just multiply your denominators. They'll wash out at the end. So we found the LCD. Once you do that, multiply the LCD to each term. What is a term?
And or variables involved in the addition.
So how many terms do we have here? No.
Say 3.
Why?
3 over 4x. That's the first term. The second term is -1, and the third term is 7 over 5.
We have 3 terms. A term is anything separated by plus, minus, or equals. And it doesn't count if the plus or minus is inside parentheses, because if it's inside parentheses, that's one number. For example, how many terms do we have here? How many?
6.
2. Because the plus or minus is inside the parentheses. So this is one number. It's actually 2 times this number. 4 times this number. So if it's inside parentheses, whatever's inside the parentheses is one term, one number. If it's got a coefficient, then it counts as one term. So here we have 3 terms. So multiply the LCD to each term. All that means is anything separated by a plus, minus, or equals, put parentheses around it. And then put the LCD in front of it. So this is what you would have. 20 times 3/4 x minus 20 times 1 equals 20 times 7 over 5. The rule of multiplying fractions. Because remember, these numbers are actually fractions. They're 20 over 1. They're rational numbers. The rule of multiplying fractions is reduce before you multiply. Can anything on top cancel with anything on the bottom? So in this first one, can anything on the top cancel with anything on the bottom? Yes. The 4 goes into 20 5 times. There's no bottom number here, so I can't do it. How about this one? It's got a bottom number. Remember, this one's the same as 20 over 1. This one's 20 over 1. So anything on top cancels anything on the bottom. The 5 goes into 20 4 times. So this is what we have left. These two equations are the same thing. Which one looks easier to do? The bottom one. That's right. That's what this whole process is about, is to rewrite your equation to get rid of the fractions. So now the anxiety stress is gone. So once we reduce, we have to multiply to get rid of the parentheses. 5 times 3 is 15. X. There's a minus. So negative times positive is negative. 20 times 1 is 20. Equals positives. 4 times 7, 28. And the last step, good. Whenever you get rid of parentheses, the first thing you should always do is combine like terms. Always. Now, solve your equation. We're solving for X. So what do we have to do? Add 20 to both sides. We have 15X equals 48. And then divide by 15. So this gives us X equals 48 over 15. Is that a final answer? Why not? For two reasons, actually. It was the second one. Is it improper fraction? Yes. Improper fraction is if the bottom number is smaller than the top. Because a fraction should always be a small number over a big number. This is improper. Improper fractions, to say it's 5 over 2. 2 goes into 5 how many times? With how many left over? They become mixed numbers. So improper fractions become mixed numbers, and the bottom number always stays on the bottom. So what we have to do here is, before we look at that, can they simplify? $15 is made up of 3 times 5. Can 5 go into 48? No. Why do we know it's no? Because, yes, a number is divisible by 5 if it ends in a 0 or a 5. So it's not divisible by 5. Is it divisible by 3? It's divisible by 3 because if you take 48, if you take the numbers and add them together, is that number divisible by 3? Yeah, if that number is divisible by 3, then 48 is divisible by 3. So 3 goes into 4 how many times? With how many left over? 1. 3 goes into 18 how many times? 6. So it simplifies to 16 over 5. And that's one of the reasons I was late today, is because I was making a whole bunch of copies for y'all. And it didn't print out the inequality sheet or the rule sheet that I wanted, but I got everything else. So what does this mean? 5 goes into 16. How many times does 5 go into 16? 3 times 5 is 15. Subtract, you get 1. So this is your number out in front for the mixed number. The 5 has to stay on the bottom. And this is your remainder. So this number goes here. This number goes there. And this number goes there. Because it's an improper fraction, it's always going to have a remainder. And I think the computer system will take both of these answers. It's just you have to be aware that the real world of mathematics will not accept improper fractions as answers. You're not done with it until you get it into a proper form. So that's just a side note for that. Example 2. 2 times 5 minus 3x equals 8 minus 3x plus 2. Notice there's no instructions. What is it telling us to do? Yeah. Solve. Since there's an equal sign. Since there's only one variable, it's solve for x. That's what it's telling us to do. Well, go ahead and work it out. And I'll work it out. Can we do anything inside the parentheses? No. So let's get rid of the parentheses. 2 times 5 is 10. Positive times negative is negative. 2 times 3 is 6. There's 8. Now, negative times positive is negative. 3 times x, 3x. Negative times positive is negative. 3 times 2 is 6. Remember, we have to get rid of the special operations first. Once you get rid of parentheses, combine like terms. There are no like terms on the left side. What do I mean when I say like terms?
So a number with a variable constant like 3x, combined with a number, another number with the same variable on it. I believe.
It has to, if it has a variable, it has to be identical variables. Those are the terms. Yes, and x squared cannot. So they have to be identical. So in this case, we have 8 and negative 6. 8 minus 6 is 2. Minus 3x. Okay, here we have one of our first hurdles. We're solving for x. If you have x's on both sides of the equal sign, then what do? You have to move one of them to the other side. Which one do you move? What do you mean bigger one? Actually, it's just the opposite. Because which one's bigger, -6 or -3?
Negative. No, negative.
Why is -3 bigger? It's farther to the right on a number line. So then move the smaller negative to the larger. Or actually, I say move the smaller number to the larger. It's always going to work that way. Doesn't have to be negative. Just move the smaller number to the larger number. So since -6 is smaller than -3 because of the number line, -6 is less than -3, we have to move -6. You notice we're not moving the numbers first. We're moving the x's because we have to isolate the x first, and then everything else goes to the other side. How do we get rid of -6? Add 6 to both sides. 6x. So those cancels. We have 10 equals 2. They're opposite signs. Take the sign of the larger. 6 minus 3 is 3x. Once you have all the variables to one side, everything else goes to the other side. This one does not have an x, so it's got to go. It's a +2, so I subtract 2. 10 minus 2 is 8. Yeah, so this is the reason why if we move the smaller to larger, we'll always have a positive coefficient in front of the variable. Now, all I have to do here to get x by itself is divide both sides by 3. So x is equal to 8/3, which is the same thing. How many times does 3 go into 8? With how many left over? No, that 3 always goes in the bottom. Again, it should take both of those answers. Would it make a difference if we moved the other number? What difference would it make?
Well, that's what I did when I tried to solve it the first time, and it meant that all of my multiplication ended up being different, and I got a different answer.
Yes, and I'll show you why. Again, it's all because of the signs. So I'm starting from this point here. This point here, where I move the smaller to the larger. A lot of students are forced to memorize, move all the variables to the left side. That's not a rule of math. That's not even something anybody suggests. It's always move the smaller to the larger. So let's pretend we move everything. So we get rid of the 3. So we add 3x to both sides. The 3x cancels there. So we have 10. Since the signs are different, take the sign of the larger number and subtract 6 minus 3 is 3x. The 3's cancel on that side. Subtract 10 from both sides. They're different signs. Take the sign of the larger and subtract. 10 minus 2 is 8. I'm going to try to beat it out of y'all. Never divide by a negative. Because I know you guys are thinking, oh, we're going to divide by -3. No. If you do that, it'll work sometimes, but it'll not work sometimes as well. Because of too many signs anyway. You have the equal sign, you have the dividing line, you have the negative sign. What if the top is negative also? So first thing you do is, since the coefficient is negative, just change the signs all the way across the entire equation. Anywhere you see a minus, change it to a plus. Anywhere you see a positive, change it to a negative. So we have 3x equals 8. Just change the signs across the equation. Now we divide by 3 and the same answer. So it doesn't matter how you move it. It's just that you have to remember you'll have a negative coefficient to worry about. So what does this tell us? This tells us that our equation has a solution. So example 3. Negative 24x plus 7 equals 17 minus 24x. Here we have another situation where we have x's on both sides. We have to get the x's to one side. So since they're both the same, it doesn't matter which one we move. How do we get rid of negative 24x? Add 24x to both sides. You notice how I always keep them aligned. So negative 24 plus 24 cancels. So it gives us 7. Negative 24 gives us 17. Does 7 equal 17? No. Whenever this happens, if your x's disappear or are canceled out and the equation remaining isn't a true statement, there are no solutions. No matter what x you try to put in there, it won't work. As opposed to this next example. I know what you're going to say. Let's add 1/3 x to both sides. But let's follow the procedures that we talked about for future reference. We have an equal sign. We have a fraction. So what are the 5 steps to get rid of the fractions? Find the LCD. What's the LCD in this case? Yeah, it's the only D in this case. How many terms do we have here?
So is it actually 2 terms or 4?
4. Because there's a minus sign, there's a equal sign, and there's a plus sign. Is that a minus sign? No, it's a negative sign. So on both, we have 1, 2, 3, 1 term, 2 term, 3 term, 4 terms. So step 2 says multiply the LCD to each term. So the LCD is 3. So I'll put 3 times the first term minus 3 times the second term, 1/3 x, equals 3 negative 1/3 x plus 3 times 3. So each of these terms, I put them in parentheses and multiply by 3. Third step. Reduce. So in other words, here's where you cancel all the bottom numbers. So the 3 and that 3 cancel, goes in there one time. 3 goes into 3 one time. So this is what I have left. I just brought down everything I have left. The fractions are gone. Multiply to get rid of the parentheses. 3 times 3 is 9. Negative times positive is negative. 1 times 1 is 1, so it's just an x. Notice, if there's no number in front of a variable, it's automatically a 1. Positive times negative is negative. 1 times 1 is 1, so it's just x. 3 times 3 is 9. And then the last step is solve. There's same x's on both sides, so I add x to both sides. Which now leads us to this. Does 9 equal 9? Yes. So that means you have an infinite number of solutions. Any x you put in there is going to work because both sides of the equation are equal. So if all the variables disappear, only 2 situations can happen. Either the numbers are going to be not equal to each other and you have no solutions, or they're going to be equal and you have infinite solutions. Any questions so far? All right, let's look at example 5. Now we're getting into word problems. Word problems. Words in languages. There are about 232,000 words in the Japanese language. That is 19% more than the words in the Russian language. How many words are in the Russian language? What we have to do here is, the first thing we have to do is we have to find the math equations for these statements. There are about 232,000 words in the Japanese language. So J equals 232,000. That's what the first sentence tells us. The second sentence tells us what? That is 19% more than the number of words in the Russian language. So how do we put that in math?
Would that be 19x?
No. So let's look at, if the Japanese and Russian language were equal, if they both had 232,000 words, that'd be great. But Japan, the Japanese language has more words. How many more words? 19% more. 19% of what? 19% of the words in Japanese language. So since it says more than, to make them equal, I have to add 19% of the Japanese language to the Russian language to make them equal Japanese language. And then looking at how many words are in the Russian language. So we're solving for R. So we have J equals R. We have to convert this. 19%. The word percent means over 100. So this is 19 over 100, which is 0.19. The number of zeros tells you how many decimals to move to the left. So it's 0.19J. So how do we solve for R? What do we have to do?
We plug in.
No, we're not yet. We have to solve for R first. How do we get R by itself? There's no 232 here. We're just looking at this equation right here. We're trying to get R by itself. What do you have to get rid of to get R by itself? The 0.19J. I mean, it's nothing hiding there. It's just there. How do you get rid of the 0.19J? Because it's plus, I got to subtract 0.19J from both sides. You're trying to read way too much into it. So we have on the left side, we have J minus 0.19J equals R. So what's the number in front of J here in the first one? What's the number in front? 1. So 1 minus 0.19 is what? So we have 1 minus 0.19J. So we have 1.00 minus 0.19. You can't do 0 minus 9, so we have to borrow 1. So 10 minus 9 is 1. 9 minus 1 is 8. So it's 0.81J. So that's this tells how many words the Russian language has. So what is J? How many words are in the Japanese language? 242,000. 32, I'm sorry. 232,000. Let's simplify this. So since we have 2 zeros here and we need 2 decimal places, I can get rid of these 2 zeros and make it into 81,2320. You don't need calculators to do this stuff. Just know what these numbers mean. So 2320 times 81, 0, 2, 3, 2, 0, 16, 24 plus 1 is 25, 16 plus 2 is 18. So this number, The number of Russian words is 185,600. That's how many words in the Russian language. So the problem with this topic, twofold. You were not introduced or kept using word problems in your high school and junior high career. Elementary schools, that's all you had are word problems. But the older you got, you went away from word problems. And then you use calculators too much. Third problem, actually, you were never taught to read for specific information. When you do word problems, we have to read for specific information. What do these words tell us? Not who's the hero, who's the victim. No, what do these words tell us? How do they relate to each other? All right, let's look at example 6. Yeah. Right.
So maybe I just haven't done like multiplication by hand in a while. Would you add the 2320 and the 185,600?
Oh yeah, it would. Good. You're right.
Okay, all right, I'm glad.
You're absolutely correct. I just went too quick. Yes. So I was looking at the audience and I see mostly blank stares. So how did you do it without a calculator? It's magic. Ex- Example 6, convenience stores. In 2014, there were 151,282 convenience stores in the United States. The total number of stores in Texas and California was 26,379. There were 4,003 more stores in Texas than in California. How many in both states? So what does that mean? What does the first sentence tell us? Yeah, it just tells us that there are 151,282,000 stores in the US. That's all the states. What does the second sentence tell us? Right, so Texas plus California equals 26,379. So here's our equation. We have one equation and two variables. We have to narrow it down to one variable. So now we have to see how are Texas and California related? What's the third sentence tell us? There were 4,003 more stores in Texas than California. So how do I put that in a math sentence? There are 4,003 more stores in Texas than California. What we're looking for is, are they equal? No. Who has more? Texas has more. So what do we have to do to make them equal? How many more stores does Texas have? To where? We have to add 4,003 to California. Now they're equal. We also know what T equals. T equals C plus 4,003. So we go back to our equation. Anywhere I see a T, I substitute C plus 4,003. So it's C plus 4,003, that's T, plus C equals 26,379. Combine like terms, we have C plus C, we have two C's plus 4,003 equals 26,379. To get the C by itself, I gotta subtract 4,003 from both sides. I have 2C equals 9 minus 3 is 6, 7 minus 0, 3 minus 0, 6 minus 4, 2. Now I got to divide by 2. So the number of stores in California, 2 goes into 2 one time, 2 goes into 2 once, 2 goes into 3 once with 1 left over. 2 goes into 17 8 times with 1 left over. 2 goes into 16 8 times. So California has 11,188. How many stores does Texas have? Do we know what the formula for Texas is? Yeah, we know Texas equals California plus 4,003. That's what we found up here. So whatever that is, whatever C is, so 11,188 plus 4,003. 8 plus 3 is 11. 9, 1. So Texas has 15,191 stores. How do we check this answer?
Plug in your value you got for C and your value for T and you solve it and make sure that
Yeah.
equals.
Add these two together, see if it equals 26,379. So we have 8 plus 1 is 9. 8 plus 9 is 17. 1 plus 1 plus 1 is 3. 1 plus 5 is 6. 26,379. That's how many we're supposed to have. T plus C equals that. You have to learn how to read for specific content, not just general information. All right, let's look at, now we're going to look at what are called motion problems. Things that move. Whenever we deal with things that move, we use time. Motion problems are defined how far something moves from point A to point B. So that's the distance. The formula for distance is the rate, the speed of this object. Times time, how long it's been traveling. So distance equals rate times time. So what if you wanted to find the rate? What would, using this formula, what would R be? D over T, because you divide both sides by T. And if you think about it, distance is in miles, T is in hours, miles per hour. That's how fast you drive. What if you want to know the time? If you're solving for T, that's distance over the rate. All right, so let's look at the next example. example 7. Delta Airlines fleet consists of 737s, which have a cruising speed of 517 miles per hour, and Saab 340s, which have a cruising speed of 290 miles an hour. Suppose that a 340 takes off and travels at its cruising speed, which is 290. 1 hour later, the 737 takes off at its cruising speed, same direction and everything. How long will it take the 737 to overtake the 340? They both take off from the same place. They both go in the same direction. It's just that the 737 travels faster than the 340. At what point, how long will it take the 737 to overtake the Saab? What are we looking for here? Yeah, how long? How many minutes or hours after takeoff will it take for the Boeing to overtake the Saab? Or more so, when will they be equal? Because anything after that point, the 737 is going faster. So, whenever you have word problems with multiple parts to it, create tables. So let's see. Here we have, in this case, here we have the plane. We have the 737 and we have the 340. It's a motion problem. Why is it a motion problem? Because they're flying through the air. So we have to use this formula. Distance equals rate times time. So we have distance equals the rate times time. So what do we know inside these boxes? Do we know the distance? No. The only thing we know is when they overtake them, the distance has to be the same. They have to be the same distance. Do we know the rate? How fast does a 737 fly? 517 miles per hour. And the Saab goes at 290 miles per hour. Here's the problem. The only thing different between these planes is when they took off. So they both deal with some variable here. Did they take off at the same time? Who took off first? The 340. So it took off 1 hour in advance. So whatever time you have, 1 hour ahead is the Saab. So what we have to do is the distance of the Boeing and the distance of the Saab, they have to be equal. What's the formula for distance? Rate times time. So we have the rate times time of the Boeing and the Saab. So what is the rate of the Boeing?
So 517.
517. And the time? We don't know, we just put X. So it's X. Is equal to the rate of the Saab, which is 290. And its time is X plus 1. So we're gonna solve for X. What does the X represent? The time of what? Of what? Of the Boeing, because X represents the Boeing's takeoff time. Or how long before it reaches it. So what we're gonna find here is the how long after the Boeing took off. So solve for X. 517X. 290X. 290 times 1 is 290. We have X's on both sides, so we move the smaller to the larger. So we subtract 290X from both sides. So we have 7 minus 0 is 7. 1, we can't do that. So 11 minus 9 is 2. 4 minus 2 is 2. So 227X equals 290. They both divide both sides by 227. So whatever this value is, what units will it have?
What do you mean, what units are?
Well, we know the rate of the airplane's miles per hour. So what units are time? Is it seconds, minutes, hours, weeks, days, months, years? Why does it have to be hour? Well, yeah, because the question said 1 hour later, and the speeds are miles per hour. So all the units have to be the same. So this is how many hours it's going to take. Is it going to be greater than or less than 1 hour? Greater than 1 hour, because it's in a proper fraction. But it's less than 2 hours. It's about an hour and 24 minutes. Okay, I'll try to hurry up this next one. Now it gets a little easier. Whenever you borrow money, you have to pay for the right to use it, to borrow it. Credit cards, buying a house, buying a car, borrowing money. That is called interest. Interest is the amount of money you pay simply to borrow set amount of money for set amount of time. The simple interest is the easiest. Simple interest is, okay, if I'm going to give you $100, I'm going to charge you $10 for borrowing it. So how much will you owe me back? 110. That's it, just flat out. No matter if it took you a month, a day, a week, an hour, it's just we agreed to that and that's it. That's simple interest. Then we have compound interest. Compound interest can be compounded, meaning they can add a fee to it each day, each week, each month, each year. They could adjust it however they want to. And if you agree to it, then the money you borrow, that $100 can easily become $4,000 or $5,000. That's how much you pay back. For example, now credit cards. If you have a credit card that has 25% interest, interest rate. That means for every $1 that you borrow and you pay back, every $1 you pay back, your 25 cents of it goes as interest. That's just paying money to borrow their money. So whenever you pay them back, you're only paying back 75 cents per each dollar you pay them. People used to thought 9-10% was bad. Now there's no limit, which is why it's important on who we elect into office. It's not a political campaign or anything. It's whoever has whoever controls the purse strings controls our lives. So be very careful. So simple interest is just that. Interest is principal, the amount, this is the amount borrowed times the rate. What percent of that amount are you going to be charged? Times time. How long you will keep the money. So you pay me back. So interest equals PRT. That's simple interest. The rate is usually given in percent. So we have to convert that into a decimal. So 5% interest is what in decimal? It's 5/100, which means if there are two zeros, you move it to the left 2 spaces. So it's 0.05. %. This is 25/100. It's just 0.25. So it's decimal 2 to the left. That's just the interest. The amount you pay back that's called the annuity. That's how much the note is worth. The reason they call it note is back in the old days, when people borrowed, they used to sign IOUs. That wasn't a piece of paper, it was a note. I borrowed $100, promised to pay you back $110 by a certain time. So, in other words, the annuity is the initial principal you borrowed plus the interest. You see these commercials where these companies want to buy your annuity notes, but they won't. If companies, like insurance companies, don't pay you $10,000 for an injury, but they're going to pay you in monthly installments, and you need the money now. So companies say, listen, this note is worth $10,000. I'll give you $8,000 now if you give me that note. But people say yes to that because they need the money now. So that company just made $2,000. Very clear. Anyway, let's look at example 8. The Marians' 2 students loan total $28,000. One loan at 5% simple interest, the other at 3% simple interest. After 1 year, the Marian owes $1,040 in interest. What were the amounts of each loan? I think it's interesting because they use 1040 because that's the tax form you file. So let's look what we have here. This is example 8. So Demarian has 2 student loans. Let's call them A and B. A and B. What do we know about those? They total $28,000. So loan A plus loan B equals $28,000. One loan is at 5%. Let's call that for loan A. One loan is at 3%. Simple interest. For 1 year, because after 1 year, Demarion owes 10,000 or $1,040. So let's look at our table here. We have simple interest. So we're gonna have, let's look at these. PRT. Here's our note. So note A and note B. The principal, the amount borrowed. The rate. The time. This is the interest. Remember, the question said simple interest. So simple interest formula is PRT. So it's principal times rate times time equals interest. Do we know how much you borrowed from loan A? So let's say it's X. That's when we don't know what it is. If he borrowed X dollars for loan A, how much did he borrow for loan B? We do know, because he borrowed a total of $28,000. So it's $28,000 minus whatever he borrowed for X. So if he borrowed $8,000 for A, how much did he borrow for B? 20,000. So together, both of these have to equal $28,000. So the rate of loan A was 5%, which is 0.05. And loan B was 3%, 0.03. What's the time? 1 year. So let's look at the interest. The formula for interest is PRT. So we have 0.05 times X times 1. And loan B is 0.03, 28,000 minus X times 1. Because all we're doing is, once we define these 6 elements here, we now can figure out the formulas for interest. If we add up all the interest, how much do we owe? We owe 1040. In other words, it's this interest plus this interest has to equal 1040. So we have 0.05 times X plus 0.03 times 28,000 minus X has to equal 1040. I left off the time because it was on 1 year. Anything times 1 is itself. So what we're gonna do here is what? We're solving for what? And what does X represent? How much we borrowed under 5% interest, right? So we have 0.05x. So we have 0.03 times 28,000 minus 0.03x equals 1040. So we have 0.05x minus 0.03x. What is 0.05 minus 0.03? Minus 0.02x. Now, 0.03 times 28,000. I have two zeros here that can move the decimal back over here. So we have 3 times 280. 3 times 0 is 0. 3 times 8 is 24. 3 times 2 is 6. So it's 840 equals 1040. Subtract 840 from both sides. We have 0.02x, 0.002. How do we get rid of the decimal in this one? If we multiply it by 100, that moves it 2 decimals to the right. So if we multiply by 100, both sides, it moves the decimal to, so we have 2x equals 20,000. We have 2 zeros there. We add 2 more zeros. Divide by 2. The amount borrowed at 5% is $10,000. What was it at 3%? Yeah, 28,000 minus 10,000 equals 18,000. So 18,000 at 3%. Yeah, look at the other two example stuff. I just want to get to the last part before we dismiss. 8 and 9. Example 9, since we're dealing with perimeters, what's the perimeter?
What is the parameter? That is the sum of all sides.
Yeah, it's the outer edge of something. Like it's like how much paper do you put on a box? So the perimeter formula for a rectangle is 2 length plus 2 width. Because we're adding, we have the 2 lengths and the 2 widths. So you add all 4 of those. That's the perimeter. So you find out what they are and put them in there. Zeros of linear equations. If I give you an equation, and I ask you to find the zero of f of x, bless you, is where f of x equals 0. So what x value makes the whole equation equal 0? So set that equal to 0. Remember what I said earlier. This is a solution. Another name for solution is 0. Another name for it is x-intercept. If you set f of x equal to 0 and solve for x, what are you finding? Remember, f of x is the same thing as y. If you set y equal to 0 and solve for x, what did you just find? Look back in your notes. How you find the x-intercept? Set y equal to 0, solve for x. So when you look for zeros, you set the y equal to 0 and solve for x. That gives you your x-intercept. That gives you your 0. Make sense? Holy smokes, we went further than I expected. And last time I looked at it, it was like 25. I'm so sorry. But the beautiful thing is we finished the section. We only have to do one more section and then we're done with this chapter. So, any questions about this?